All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to be learning about tur- the Turbofish syntax in Rust. I've had a hell of a time getting this stream started because it was all just one technical difficulty after another. Um, but yeah, I just well, just a second here. Yeah, there we go. Okay, so we're gonna be learning about the Turbofish syntax in Rust. Give me a second while I open up my chat on my phone. Okay, we are good to go. One last thing that I need to do is this. I need to search for Rust Turbofish because this is an interesting concept and this term actually has some history behind it. You guys can do your own research around what the history surrounding it is. Um, just a second. Let me open this up. Okay, okay. Is that loaded? Great, cool. Oh, there's the idea of blanket implementations in here as well. So what I'm opening up in my browser is the glossary, which is gonna give some very basic information about Turbofish. But in that information, it does also link. Hold on, here it is. We can get rid of that. Oh wait, what's the? Yeah, there. We can get rid of the highlight. Um, this is something I do want to read later on. I haven't had the time to read this all the way. It's within comments, and this is in the official Rust repo. Um, yeah, I was reading up on this yesterday, and the person who coined the term as well, and just a lot of stuff surrounding this. I haven't had the chance to read this entire thing. I don't really know if this gives information or if there's something else around what is, you know, whatever is within this text. But I'm gonna spend some time reading it later on. For now, though, I do want to learn about Turbofish. I am interested in the concept uh, of the Turbofish. So what I'm gonna do is I've opened up a Gemini instance here, and I'm gonna ask Gemini to explain Turbofish to me. So I'm learning Rust, and I've just come across something called Turbofish, Turbofish syntax. I would like to learn about this. Um, Teach me. No right actions necessary. Just give me the info. Okay. Uh, Hold up. Yeah. Okay. So, dude, yesterday I spent some time looking into the whole compiler thing and doing some research about the various stages. It was actually really enlightening because I got very, well, it was, I don't know if enlightening is really, I mean, enlightening works, but it was a very educational thing to do. It was very informative. I got to learn a lot about the various compilation stages, and we narrowed down why exactly it was showing a specific batch of errors first, and then it was showing the other batch of errors. So first it was showing the missing arguments errors, and after that it was after we solve the missing arguments errors, after that it shows the move errors. I actually have that set up here. Hold on. You guys are probably able to see this code. Let me just rename this back to sum underscore func o2 and save. So you can see over here it mentions this missing argument thing, right? But there's also supposed to be an error up here, specifically on this line, not this line. Specifically on this line, there's supposed to be a move error, but the Rust compiler or the analyzer, neither of them is complaining about that right now, and that's kind of what got me to do all this research. So I found out that your code goes through multiple stages. One of the stages is the code being converted into an abstract syntax tree. From an AST, it gets converted to HIR, which is high level intermediate representation. And in HIR form, there's a bunch of checks that are performed. One of those checks is well, one of those groups of checks is type checking. And under type checking, you have something called arity or arity checking. I'm calling it arity. I don't know how it's meant to be pronounced. Arity, arity, whatever. I'll look into it. The whole idea with that check is that it's supposed to check for stuff like function call, argument counts, and stuff. So that is where this error comes up. Now, up until this point, we or the compiler hasn't yet done any sort of borrow checker related checking, and that's because that doesn't happen when the code is in HIR form. After a bunch of the checks are done in on the HIR is then converted to MIR, which is mid-level intermediate representation, and then there's a bunch of checks that are performed on the MIR. One of those checks is the borrow checker related checks. So that's when the move related error shows up. And during these various phases, if an error shows up in one of the phases, then the compiler just doesn't continue further into the next phase, and that's kind of why we don't see the errors from that specific phase. So that explains why we first see the function argument related error, and if I solve that, now we see the move related error because this has to do with the borrow checker. All right, let's go take a look at this. Okay, so of course, let's break down Rust's Turbofish syntax. What is Turbofish? Turbofish is the unofficial but widely used name for so-and-so syntax in Rust. It's used to provide explicit type arguments to a generic function or method when the compiler cannot infer them on its own. Let me read that again. It's used to provide explicit type arguments. It's used to provide explicit type arguments to a generic function or method when the compiler cannot infer them on its own. It looks like this. Okay, all right. The name comes from its appearance. The two colons looks like the eyes, and that looks like the body and tail of. Oh, now I'm able to imagine the fish. Okay, all right. And now it also makes sense that, it's swimming to the left. Okay, all right. So that looks like the body and tail of a fish swimming to the left. Give me a second. Let me just look at my OBS and make sure Everything is fine. I think we are good. Yes, okay. We are good. Cool. So, where was I? What was I gonna do? Yeah, okay. So, we are continuing reading this. Why is it necessary? The problem of ambiguity. Rust has a powerful type inference system. Most of the time, you don't need to explicitly tell the compiler what the types of your variables are. However, sometimes a situation is ambiguous and the compiler needs your help. The most common scenarios involve generic functions or methods that can return different types. Okay. Classic example, collect. The collect method on iterators is the poster child for Turbofish. It can gather items from an iterator. Hold on. I lost where I was reading. It can gather items from an iterator into any type that implements the from iterator trait. This could be a vec t, a hash set t, um, a string, etc. Let's say you have an iterator of numbers. Okay, hold up. This is how you do it. I've been wondering how you do something like this. I should look into using the map function. I guess we're gonna get to that later on in the Rust. Speaking of which, hold on. I need to um resume. Give me a second. I don't know what all it's gonna show. So hold on. Let's do that and let's resume. And what I need to resume is one of the really old conversations that I have. Oh, that conversation, yeah, I don't think that conversation was in this directory. So maybe let's quit this and go back one step and open up Gemini here and then resume from there. Because I need to get back to that conversation. I need to, dude, holy shit. I need to finish this long ass Rust tutorial that I've set up and then export the entire thing before I lose all of this information because I want to post this eventually. Oh, okay, okay. Okay, so I'm glad to see that this is holding information from 4 months ago. I'm super glad to see that. Like, legit. I'm super glad to see that. I just don't know where exactly was that? Was it in empty directory? I can't even remember if it was in empty directory because I'm not seeing it here. Why am I yeah, okay. I can dig for this later on. For now, I am curious. I need hold on. Uh, was it rustproj? It can't be rustproj or empty directory. Oh, Gemini rust. Hold on. That might be it. Um, let's go VS Code projects, Rust. What all do I have here? Gemini Rust Learning. I think that's where it might be. Yeah, give me a second. I'm gonna open up Gemini in this directory and then see if I can retrieve the entire conversation because I don't want to lose this conversation. There's so much in here. You are a tutorial creator. You're going to teach me Rust. It says age 3 days though. How is it counting the age? I'm curious about that. Let me just open this up and see where we were. This ended at transforming numbers, iterators. This is the one. So age, I think it's counting the age from like each time I resume it, the age kind of resets. And so now it's saying age 3 days because I think maybe 3 days ago I had to close this conversation and reopen it or something. And yeah. Or because like when you think of age, you would think like, oh, from the very beginning, right? When did this start? But could age in this case mean when was the most recent message? Because the most recent message, yeah, that probably would have been 3 days ago because we stopped at iterators and I started like diving deep into the concept of iterators and into iterator trait. And I think there's an iterable trait. I don't remember. And then like that led me down a rabbit hole. Okay, I can transition now. Okay. Uh, but yeah. This is going to be taking us into a bunch of different things. There's map, there's closure, there's take and skip, and then here we have collect, which says it collects all the items into a new collection. All right. So, uh, right. So what is this saying? Let's say you have an iterator of numbers. Okay. Okay. What does map do again? It applies a closure to each item, producing a new iterator of transformed items. So it's on every item. And if you want to do it on specific items, you would then filter. Or if well, I don't know if you can actually perform operations in the filter. You can use the filter to provide a condition to filter stuff. And then maybe on that you could call map and do your transformation. Okay. Anyways, um, okay. Now you want to collect these numbers, but into what? A vector, a hash set? The compiler doesn't know. The solution, type annotation, the usual way. Okay, okay. Oh, oh, that's interesting. Okay, so this returns something, but like, what are you returning it into? That's okay. Wait. I need to test this out. So we can delete all this code because I'm not using this anymore. We can delete this as well. We can delete this as well. Okay. All right. Um, what was I gonna do? So there's a range, right? Out of a range, so we can feed a range into. How does that? Wait, no. Hold on. That example that was given. So let's say um. Wait. Let's comment out all this code. Okay. Let a equals. Sorry, zoned out. Let a equals 0 to 10. But then this is a range, right? And then you apply a map to this, and this returns an iterator then. This is returning, well, this is returning a map. What do you do with the map exactly? Like, how does that get converted into something? So like, okay, let's say, or okay, this is returning a map. We can also just say into iter. Sure. Or can we just do iter? Okay, there's no iter. There's into iter. And we can specify a type here, which is vec I32. Does this work? This does not work. Okay. So if I do map and then I create this and then return this, uh, let's get rid of that and that. Okay, mismatch types, expected struct vec I32, found struct so and so. Okay, so it's still throwing an error. What's this? Hold on. Is Gemini getting this wrong or did I read this wrong? Oh, there's collect. Holy shit. Okay, that's my bad. Um, so then I would need, this has to be an iterator for me to be able to call collect on it, right? I can't just call collect right now. I can. Okay. Wait, so ranges are iterators? Hold on. Something that implements iterator, right? Not implements into iterator, but iterator specifically. Would I be able to call, let's say, some func o1, um, and let's pass that range in? Yeah, okay, that works. So I'm guessing then range is an iterator. Okay, so what does collect do? Collect returns. Oh, wait. So collect takes a type and then returns that exact type. But then what is the type here? The type B is vec I32. What happens if I didn't specify this? Okay, so we have the error here. Type annotation needed, cannot satisfy so and so from iterator I32. Type must be known at this point. Consider giving A an explicit vec. Right. So here we can see that it's not showing anything after self. It is just like there's nothing there. So B is not being mentioned. And that's interesting because, okay, B is supposed to be from iterator, and that's supposed to have an, B is supposed to be from iterator, which I don't know if range is from iterator. Is range, would range be considered from iterator? I'm also just realizing that this is from iterator, not into iterator. It transforms an iterator into a collection. Collect can mean anything iterable. Collect can take anything iterable and turn it into a relevant collection. This is one of the more powerful methods in the standard library, used in a variety of contexts. The most basic in which the most basic pattern in which collect is used is to turn one collection into another. You can take a collection, call iter on it, do a bunch of transformations, and then collect at the end. Okay. Uh, Hold on, there's more text here. Collect can also create instances of types that are not typical collections. For example, a string can be built from chars, and an iterator of result uh, te items can be collected into result collection t and e. Okay, okay. All right, because collect is so general, it can cause problems with type inference. As such, collect is one of the few times you'll see the syntax affectionately known as the turbofish. This helps the inference algorithm understand specifically which collection you're trying to collect into. Examples. Oh, they're not using Turbofish here in any of the examples. Well, that's okay. I mean, we have the Gemini thing here. Okay, now you want to collect these numbers, but into what? This is interesting. No, this is really interesting. Looking into this collect method. So this collect method, it takes. How is it getting its type though? What would item can I access item on range? Um, hold on. So the trait has the item, right? I would be able to do self dot item. So would I be able to do sorry, zoned out. Okay. Um, what was I gonna look? Oh yeah. Okay, let's delete all this and see if I'm able to access. No, I can't access item here. We have collect. Okay. Um, okay, it's range I32, meaning the item in this case would be I32, right? Would it? Yeah. Yeah, if self um is that necessary? Because like no, wait. If let's say we implemented a struct. So wait, let's create my struct o1, and this can be a generic struct that doesn't that doesn't really do anything with. I mean, okay, we can do a t and then we can pass in an I32. Okay, then we create a trait, my trait o1, and this is supposed to have a type item, and that's about it. Now, if I'm implementing my trait o1 for my struct o1, this is where I need to take care of the the generics, not all trade items implemented. Okay, yeah, yeah. Actually, would code actions give me something here? Alternatively, use a blanket implementation to implement my trade for all. Oh, wait, no, that's going to become confusing. Though I'm glad that there is the option for a blanket implementation. Implement missing members. Yeah, there you go. And now the issue is, wait, expected a type and found trait. Do we not need to do it here? I'm not sure. How, wait, how are, oh, this is, wait, no, I was supposed to do my struct, not my trait. All right. So, um, now can we access item? Is that a thing? Let's take a look. So we can do my struct. That's not possible. Self is also not going to work. I could write a function that's going to return the type. That would then be a generic function, right? That's not returning. Oh, I am not supposed to be able to, um, I mean, no, why can't I? Yeah, how do I access the type for this? Because I could like write a function here, right? I could say fn some func or one. This would be this is an associated function, and this takes in actually this. Do I need? Yeah, okay. I need to declare the thing here. The name ti cannot do that because it is already declared. Okay, yeah, that makes sense. And here I need to return self item. Method sumfunc is not a member of trait. Is not a member of trait my trait. Mismatch types. Yeah, okay, that's right. So we return. What are we returning though? Like, yeah, no, I'm not even sure what I'm trying to produce here. So I feel like trying to build a function around this is going to be a little complicated because I'm trying to get it to return the type, but like it would have to be wrapped into something like option, for example, and then I could return option whatever. Um, oh, not option, sum. Also, why does this keep giving that error of it not being a member? We could do self and then now it's still saying some func is, oh wait, no, that's um oh back up. Um yeah, I need to first define this here. If I want this to be accessible from there, I just remembered. Okay, some func o1. Okay, so that issue is gone. And now I believe our issue is the return type. But then how do I give like a concrete return type? Would that, what am I putting into some t here? How are we getting? do I have access to yeah, no, I'm not sure. Um what if I did this? Mismatch type. Expected T. Can I just put T in there? No, I can't because T is not a value, so that's definitely a problem. Yeah, at this point I'm kind of confused about what I'm trying to even do. So I'm just gonna step away from this. We've done this. We can get rid of this, save all of this, and then we come back over here. Okay, this is why I was looking into it initially, right? What I was trying to do was I was trying to um, I guess access self dot item. Yeah. Um. Okay. All right. Let's continue reading this. I am still interested in like what is going on here. So collect is supposed to take in B, and B's trait bound is from iterator, where self item is the type. Self item. What would self be? Self would be the iterator, right? In this case. And so whatever value you have passed into the iterator, that is what self.item is going to be. But then what does that look like in a range? Yeah, what would that look like in a range? Because okay, so I implemented this thing, right? So this allows us to create a generic struct like so. Let b equals what was it? My struct, yeah. And then we specify I32 and a equals. Wait, is this where we specify I32? I don't remember. Let's see if that throws an error. Um, yeah, I think I made some kind of mistake here. Am I not supposed to specify the type? Okay. The type, oh, I have to specify the type here, not there. Okay. Okay. Right. So then, okay. All right. So then my struct O1 can be considered our iterator, our collection kind of thing. I'm trying to imagine this because uh yeah, I'm trying to imagine this and I'm having a hard time imagine I'm having a hard time imagining this. Uh so okay, self is range I32, right? If self is range I32, self dot item. Oh, you know what we could do? Wait, let c equals vec and then 0, 1, 2, 3, 4, and then c dot iter dot collect. Now we know So in this case, iter is our self and it holds that I32. B is returning a unit, what do you call this? Unit type. So B is returning nothing, basically. Hold on, that's interesting. B is returning nothing. What if I did D equals this, but I specified a type here that throws an, oh wait, okay. What's the issue? The method called chain might not have had the expected associated types. Okay, a value of type vec I32 cannot be built from an integer over elements of type integer. The trait from iterator so-and-so is not implemented for vec I32, but trait from I32 is implemented for it. For that trait implementation, expected I32 found so-and-so. What does iter return? Right, so in this case, we know that T is I32. And then self becomes, wait, okay, hold up. T is I32. T is I32. That means item would also be I32, right? So when we have an iter and self, oh, wait, yeah, it does mention it here. So there's self item. So then what it's returning is an iterator. It's returning a from iterator. I don't know what a from iterator is. I need to look this up. Okay, wait, let's continue with this is kind of interesting because there's a lot of experimentation that I have to do surrounding this. Um it's just like I need some time to just go crazy with a whole bunch of experimentation. Give me a second. Let me drink my energy drink and hydrate, and then I'll continue reading. Okay, holy shit, dude! Who knew that this one chapter was gonna introduce me to so many different things? Like that's insane. Closures, and iterators. I was confidently saying that I would get through both of those chapters, both of these. Well, one is those, and one is this, one is that, and one is this. Because I'm done with the closures. I'm still in iterators. But anyways, I was like, okay, this chapter I'm gonna breeze through it pretty quickly, and then we're gonna jump to smart pointers. But then now here we are, and I'm kind of just exploring a whole lot of other stuff. Um, I'm we're looking into more than just iterators here, which is a great thing. Okay, so let's take a look at this solution. I'm 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 kind of trying to reproduce this. Of course, I could just reproduce the thing with the example that's given, but then I keep getting distracted. Let's, right, let's get rid of that. And here we have collect. That's going to throw an error because type annotation is needed. Right. So, um, oh, this is interesting. I just hold on. I just noticed this. Self is mentioned here as well, but like in this definition, we only have B, and like, even the return type is B. Self is coming here from, I believe, elsewhere. It's not. No, hold on. How does that work exactly? Yeah, no, hold on. That's interesting. Can I wait? Let me try to implement something like this from iterator self item. Okay, cool. So in the trait we okay, so let's do fn some func o1, and this is supposed to take in uh item, I guess. Can I do that? I can do that. Okay. This is supposed to take in. Wait, is that what's supposed to happen? Because then you should be able to access item like directly in there. You don't need to do self dot so and so. Oh wait, here item is then gonna become a generic. I need to do self. I can't do self until I'm in the implementation. Yeah, that's not gonna work. I could then do T here as well, right? I could do that. And then in here I would need to implement fn some func o1 T um where um self is, what was the thing here? I don't know why I keep trying to like reproduce this. Self is sized. Well, sized would need to be some sort of collection, right? I think so. Yeah, sized would need to be a collection. I just need to see if this code is legal. That does not work. This works. Sized. Okay, so T is already used for a generic parameter. So we can then do B here. And we can do B is from iterator of type self item. Oh, is that okay? Okay, impl has stricter requirements than trait. Oh, okay. Yeah, how would I define, well, this takes B. Okay, wait. Where B is from iterator self doesn't work here though. I can't do that. Can I? Oh, wait, it does work? All right. Then let's do okay, B is this, and I mean if that's the case, can we also do self sized? Okay, so this works and this doesn't throw an error. Now, what am I trying to do here? This is our implementation. Okay, all right. We have some func which is also oh wait, which is also supposed to return B. Mismatch types. Oh yeah, it's missing B. It is missing B. Can I put that here though without any problems? Oh, back up. Why did I create this? Um, Wait. How do we go about how do words? How do we go about doing this? Do we need a oh that's how. All right. Okay. And then here we need to return B. How do we return B? Yeah. How do we return B? Because this is definitely complaining because of the return type, but how do we return B? Sorry, zoned out. Okay. Um, Dude, we were supposed to be looking at collect here, dude. Okay, so collect requires I guess I keep getting confused here, I keep getting distracted here because I want to try and recreate something like this. What would the implementation of collect look like here? Let me how do I go about doing this? Okay, so let's say uh let's say struct my struct o2. This is um this is an iterator, right? So we this is supposed to be an iterator. Let's not make this generic. Let's make it have like a type, but let's not make it well, no, if it's going to be an iterator, it has to. How do I make it an iterator for like a specific thing? I think that's an impl, right? Impl. Should I implement iterator or into iterator? I think it's iterator. Impl iterator for my struct o2, and then so we are supposed to be able to iterate over what in within the type, because the type itself is an iterator. Sure. Okay. Um, okay, wait. Yeah, let's implement the default members because I'm looking for collect. So there's count, there's that, and collect. Okay, so this is our definition. Okay, they've put the trait bound in here where B, oh, this is interesting. Hold up. So they, okay, that's just like a, I guess that's just a style choice. So B is from iterator. Are there any like issues here? From iterator, from iter, self. We can do that. I guess, that kind of answers the question, right? Okay, this is too aggressive to turn on for everything all the time, but PR so and so accidentally noticed that some Rust C iterators had malformed size hints. So this will help catch such things in debug assertions STD runners, even if users won't actually ever see it. All right. Okay. Okay. So this answers my question. And now I need to look into from iterator. So what is from it? Wait, okay. We can undo this. And I guess we can also delete all of this. Okay, so let's do this and from iterator, from iter creates a value from an iterator. So this requires an iterator. This requires an iterator. Okay, let's arrange as an iterator, right? Unnecessary parentheses. Okay, what about now? Okay, that works. What's interesting here is that there's no type for this. What type is this returning? From iterator, from iter, it returns self. It, hold on. It returns self. Isn't self from iterator? Yeah, I'm kind of confused. No, hold up. Self is not from iterator. Self is, yeah, no, self is from iterator because, or is self range? No, T is range. What would self be then? Self would be the collection. And so in that case, this is what's being returned here. Oh, oh, we do have an error. It just wasn't showing up because of, well, compiler stages. What is the error here? Oh, cannot call associated function on trade without specifying the corresponding input type. Use a fully qualified path to a specific available implementation. Self type. That doesn't answer my question. Though, something that I noticed here is this Turbofish. Now, why is it saying this? Cannot call associated function on trade without specifying the corresponding input type. Um, use a fully qualified path to a specific implementation. Um, hold on. I'm trying to like, because I'm having a bit of words. Holy shit, words. I'm having a bit of a brain fog moment because I haven't slept very well, and so I'm just having some trouble thinking about this. Um, so we don't have an issue when we are using from iterator within a trait implementation. Cannot call associated function on trait without specifying the corresponding impl type. Oh, back up. What did this, wait. Okay, so um, this is the, this is the bound from, or bounds from the trait itself. And then this is for this function specifically. Item equals A from iterator. We haven't specified a type here. So what is A exactly? I guess that's where Turbofish comes in, isn't it? I think so. That makes sense, right? That's where Turbofish would come in because we would then specify the type for this. What if, hold on, what if I did what's no, we still have the error. This is just me trying things because I don't really know what I'm doing here. Oh, I could just ask Gemini. Hey, I'm learning Rust. I just came across something called from iterator, and I'm trying to use from iterator from underscore iter um, this. I keep getting an error saying, what is the error saying exactly? Hold on, let me come back here and open this up so I can read it, and then come here. Saying one, cannot call associated function on trait without wait, hold up. This is not a type. This is not a struct. From iterator is a trait. Um okay, that's probably what's causing the issue. Okay, it just clicked. I do want to see what Gemini's explanation about this will be, because maybe Gemini could suggest ways that I could go about doing this thing because I've never done this before, or at least not knowingly. Um, Calling an associated function on a trait. Um, on a trait without specifying the corresponding impl type. Okay, and then two, use a fully qualified path to a specific available implementation of, let me type it out exactly as it is here, this slash, okay, self type, okay, and then this whatever is okay. Yeah, let's see what Gemini says. Okay, welcome to the world of Rust. You've just hit one of the most common welcome to the neighborhood hurdles, which is type ambiguity. The error is essentially Rust saying, I know how to turn an iterator into a dozen different things. A vec, hash set, I think this is leading to Turbofish. Okay, a vec, hash set, a string, so on, but you haven't told me which one you want. Okay. Oh, back up. Then would this work? Hold on. You're joking. That's crazy. Hold on, dude. That is crazy. And then here we have I. So now the whole thing changes because now I've specified vec, right? If I didn't specify it, let's create a different thing here. Equals from iterator, from iter 0, 1, this. Okay. So if you look here, we have A and T. We have A and T, pub trait, so and so. Okay, and then if we come up here, we have from iterator. So it's using the from iterator implementation on vec because apparently from iterator has been implemented for vec, and that is how we are able to proceed with this. Okay, we have I and then it returns vec t. But in this case, what do we have? It returns self. It returns self. That is where self comes in. Now it makes sense. That is where self comes in. So this is so far a trait. We need a self. We need a type of some sort. And that type becomes, yeah, does it? Yeah, that type becomes vec, right? Vec becomes that type for us. Yeah, yeah. Vec becomes the type for us. All right. Um, where's the proper thing? Here. Okay. All right. From iterator, so and so, so and so, into iterator, item equals t. Does it do this down here as well? Roughly. Roughly. Yeah. Um, from iterator, here item equals a. A is whatever the type is for from iterator. Also, this is interesting. The trait is generic. It's not the struct that's generic. I don't think I've done generic traits before. Have I? I don't think so. I've done generic functions and generic structs. Have have we done like generic words? Have we done generic traits before? I can't really remember ever having to type, trait so and so and then the angle brackets. Probably not. Sorry, zoned out. Okay. All right. So because from iterator is a trait implemented for many types, calling it directly as from iterator dot from iter leaves the compiler guessing. Okay, that helps me visualize it a little bit. Would I hold on? Would we have eventually reached to that same situation here, where Gemini is giving these examples? I just kind of like got distracted and started doing my own thing. Um, but I guess here it's actually giving us a pretty good example, a pretty good demonstration of why Turbofish might be required here. I do want to see what quote unquote fully qualified path means. Oh, fully qualified is basically that, but like in a different way than how I was doing it. The fully qualified path is apparently this vec and then I32. I'm guessing this is the Turbofish syntax, and then we do from, where is it? From iterator. Hold on. Wait, did I just solve the problem that I've been trying to solve previously? Because okay, earlier I had done this like back when I was like in one of the previous things where we were dealing with um actually no, it's one of the current things, not the previous thing. In the current thing we were dealing with a vec, and I was like, okay, what's a good shorthand for creating a vector? Because like okay, let's say let f equals vec, and then in here we can do this, right? I was like, that was an unintentional 6 7, but okay. I was like, what if I did this? And that doesn't work because well, it creates a vector of ranges, meaning what I could be doing is something like this. So this is a vector of ranges, not a vector of I32s, and that is not good. This now becomes a vector of I32s. So we could try something here. For I in E, I haven't done the iterator thing. Does that work? That works. Okay. And would I need to do this? Well, I don't need to do, well, okay, I should do it for the vec, so the vec doesn't get consumed. But then the values in it, actually the values should also not get consumed, right? With the collection, also I would need to make sure that the values don't get consumed. Though in this case, I don't need to worry about that. But I was just thinking about like, what if it was a string? How am I meant to be handling that? Though with a string, probably. Well, okay, so here because I did this, because I did ampersand e, it automatically made I be a reference. That has me wondering, would this be necessary? Would this even work? Oh, that's interesting. Hold on. That is really interesting. Uh, wait, when you call for in this way, does that consume does that call iter? I think that calls iter, doesn't it? Wait, e dot iter returns an iterator over the slice. I don't remember. I think Rust did have something that made it so it wouldn't get consumed when you were, I don't remember. I'm gonna have to go over that again. For now though, we can just, but this is interesting. So we take a reference to this. If I don't make it a reference, it's then it's returning a reference. But then if I make it a reference, it's a reference to a reference. which leads to the value, I'm assuming. I think. I'm not sure. But okay, what if we do this and then we do this and for the sake of running this program, where else do we have an error? Here. We can get rid of all the, yeah, we can get rid of all this. Are we good here? Get rid of this and we are good. Okay. Cargo, run. Okay. Um, right. Now, what if I remove this and then I tried to print out E over here? Here, I tried to take a reference to E. No, the thing has been, no, okay, that's a different error. I was expecting the move. There's the move error. So we would need to do this, and now we are fine. I am curious about this thing though, because we are looking at a reference to it. Oh, you know what? Yeah, the difference between passing a reference to it and passing it itself is in one case it'll either move or copy. So that is if you pass it itself, it's going to move or copy depending on whether the thing implements copy or not. And in the other instance where you are passing a reference, it's just going to read the value from there. And you can have as many of those references as you want. I feel like there's something that I'm confused about there. I just can't put my finger on what that is. This is one of those things where like once in a while I'll have this doubt and I have to have a conversation with Gemini about it because Gemini can give me like the quickest answer. And this is one of those things that, this is definitely one of those things that I've covered with Gemini before, but I've just forgotten what it is. It's something to do with references, like whether ampersand I32 is storing the address or is it storing the value or like what's going on there. Also, if I do this, would that still work? Yeah, that still works. So I'm guessing the non-requirement of it, or it not being required might just be syntactical sugar, I guess. Yeah. Okay. All right. I'm gonna continue with this because okay, so this was supposed to be about Turbofish, but like I mean to be fair, we did explore a bunch of Turbofish related stuff. I'm gonna continue exploring this off stream. For now, I'm gonna look for somebody to raid because well, it's time for me to end the stream. Unfortunately, I started the stream a little bit late. Um, give me a second. Okay, okay. Wait, what is this? This is a stream that we cannot raid right now because they seem to have gone offline. Okay, okay, I'm seeing someone here who looks like they might be having a conversation with Gemini about something. And it is a follower only chat, so never mind. Okay, okay, wait, what is this? No, okay, okay. Uh, all right, you know what? Yeah, let's go check this person out. Um, they are doing, this is a shared chat. Their name is Ichi Chan, and they are doing I think they're doing artwork. I'm not sure. I don't know. I don't know why I thought they're doing artwork. Where did I see art being mentioned? Maybe the person that they're collabing with. Okay, I don't know. So we're gonna I am not sure if if I'm even able to raid them. Give me a second. I'm just gonna. Okay, yeah, we can raid. Okay. So yeah, we're gonna head over to this person's stream. I'm gonna continue with all of this experimentation because I need the next couple of hours to just explore everything here that I'm curious about. So that's the only way that I'm going to be satisfied with it and be able to move on from it. Um, I don't think we'll be returning to the Turbofish thing. I think I might be done with Turbofish by tomorrow. I will have learned whatever I need to learn about Turbofish, hopefully. And then we'll either continue with Petgraph or we're going to continue with learning about iterators. So we're going to continue learning Rust. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.